Hi everyone. In this video, I'm going to talk a lot about sleep regulation. So, when you're in your wake state, there's a system that's actively keeping you awake instead of letting you relapse back into sleeping. And that system are usually located in your upper brainstem. As you can see here, this picture shows you kind of all the regulatory systems. And it's known as your reticular activating system, right? So these collection of neural networks in your brainstem are known as your reticular activating system. And I'm going to abbreviate it as RAS. But this system uses neurotransmitters such as serotonin, glutamate, acetylcholine, and norepinephrine to keep you awake, right? So this sends out your reticular activating systems sends out glutamate, serotonin, and acetylcholine to your cortical neurons. So remember, cortical neurons means neurons in your cerebral cortex, this area that I'm showing you right here. So let me change my pointer so you can see it. This area over here is your cortex. So any neuron in this area would be called a cortical neuron. So your reticular activating system sends these four neurotransmitters throughout your brain to keep you throughout your cortical neurons to keep you awake. But that's not the only system at play here. You have tiny neuropeptides in your hypothalamus. So your hypothalamus, remember, is the area immediately under your thalamus. It's this kind of triangular area right here. But orexin is this chemical, which is a type of neurotransmitter called a neuropeptide. So if you break the word down, right, a neuropeptide is basically a protein, right? Protein that's produced in your hypothalamus. What you need to know about orexin is that there are two types of orexin, right? Um, sorry, I need to change my color. Okay, two types, and both are obviously neuropeptides. And orexin can be is activated in response to sleep-induced low blood sugar, right? So your sleep-induced low blood sugar is basically when you sleep, right? Your metabolic processes kind of tend to kick gear, and what that results in is kind of a lower amount of blood sugar, which is a sign that your body is done with its metabolic processes and is ready to start the day again. So the way that your body knows is that obviously when you're sleeping, your metabolic processes rest and digest. They they get kickstarted a lot. But when you reach a certain point in the morning, they tend to drop a little bit lower than normal level so that your body can release orexin. And what orexin does is it has an excitatory excitatory effect on other arousal systems. So basically, orexin activates these activating systems. So orexin causes it to turn on. And what we know is that orexin basically is activated by the sleep-induced low blood sugar, which means that it's also implicated in metabolic processes. And essentially, if you wanted to take one big thing about orexin, is it controls the transition between your wake and sleep states. It controls the transition, right? And that's really important because, well, as we'll find out in the next video, that the inability or the lower amount of orexin, low amount of orexin will cause difficulties in regulating the transition. Transitions, which will then result in a condition known as narcolepsy. So maybe you guys have heard of narcolepsy as the chronically sleeping disorder or the forever nap disorder. That's how I've actually remembered this, where it's basically you can't control when you go to sleep. You can't control when you go to sleep. So this disorder helps us really understand the role of orexins because the depletion of orexin or the lower amount of orexin causes you to have narcolepsy-like effects. So basically, low amounts of orexin means a lower control on how well you can shift from your wake state to your sleep state. So on that topic, the last part I wanted to cover for this video is the balance between two neurotransmitters and their role in your state of wake or sleep. So basically, acetylcholine and norepinephrine are two of the most important neurotransmitters when determining whether you're in a wake state or which state of sleep you're in. So, high acetylcholine paired with high epinephrine, or sorry, norepinephrine, not epinephrine, norepinephrine, produces your wake state. So, high and high produces wake. The way I like to remember that is that acetylcholine is the main neurotransmitter that is associated with movement, and norepinephrine is obviously, like epinephrine, involved in arousal and thinking. So movement plus high thinking is your wake state. Then, what if you have high acetylcholine and low norepinephrine? Well, in this case, if you have high acetylcholine and low norepinephrine, oh my gosh, I can't talk today. You are in your REM sleep, right? So there's not enough neurotransmitter or there's not enough stimulation for you to actively be thinking and processing stimuli because that's what norepinephrine is mostly used for, right? Processing stimuli and responding, right? Responding. That's like even in the flight or fight response, your norepinephrine and epinephrine are constantly for you to look at a response and immediately react to the response. So kind of that quick, rapid response when that's what you need when you're awake. But when you're in REM sleep, you don't need that because you're not actively receiving any stimulus, but your acetylcholine is involved in focusing and also movement, right? Movement. Acetylcholine is highly implicated in movement, which is why you need to be paralyzed, right? When you're in REM sleep. Atonia, since you need atonia or you need the paralysis in your REM sleep, I like to remember that in REM sleep, your acetylcholine will be high, whereas your norepinephrine will still be low. Finally, the last combination that you can have is low acetylcholine plus low norepinephrine. And this state, obviously, you guys should be getting this, is your slow wave sleep, right? Because you don't have any movement really when you're in your slow wave sleep, and you're not processing any new stimulus, so you're going to be in your slow wave sleep. So that's all I have for this video. I hope that everything here made sense. I also highly suggest that you read the textbook, as this is just a snapshot of what you need to know for this section. In part two, we'll be discussing a little bit more detail about what narcolepsy is, as well as what arousal, the definition of arousal. Thank you so much for watching. Have a good day, everyone.